Welcome to Across the Globe. Today we will learn about interfaces in Go. Interfaces in Go leverage method definition for type adherence. By enforcing a specific method set, interfaces dictate the behavior types must exhibit to conform. They provide polymorphism, supporting diverse types to be utilized interchangeably. For instance, an interface defining a shape may have methods like calculate area that various shapes, e.g. circle, rectangle, must implement. This fosters flexibility by permitting any shape adhering to the shape interface to be used seamlessly in code, enhancing code reusability and maintenance. In Go, interfaces are defined using the type keyword, followed by the interface name and a list of method signatures. These method signatures define the behavior that any concrete type implementing the interface must fulfill. For example, the interface shape can be defined with a single method signature, area, that returns a float64 value. Any type that implements the shape interface must have a method named area that returns a float64 value. This allows different types like circle or rectangle to implement the shape interface by providing their own area method, enabling polymorphic behavior in Go programs. When a type in Go satisfies an interface, it must implement all the methods defined in that interface. For instance, in the given example, the type circle satisfies an interface that requires an area method implementation. The circle type has a method area, which calculates the area of a circle based on its radius. This demonstrates how the circle type satisfies the interface by implementing the required method. In Go, interfaces are implicitly implemented. If a type fulfills all the methods defined in an interface, it automatically satisfies that interface. For instance, consider an interface shape with a method area. If a type circle has a method area that calculates the area of a circle, it satisfies the shape interface. When a function like calculate area shape takes a parameter of type shape, you can pass an instance of circle to it. In the given example, a circle type with a radius of 5 implements the area method. When calculate area circle is called with a circle instance, it correctly calculates and outputs the area of the circle as 78.54. This showcases how the circle type satisfies the shape interface due to its implementation of the required methods. Interfaces in Go are like USB ports on a computer. They provide a standard way for different devices to communicate with the computer. Just like how you can plug in a keyboard, mouse, or printer into a USB port, and they all work seamlessly with the computer, interfaces in Go allow different types of data structures to work with functions that expect a certain method set. For example, you can have a printer interface that specifies methods like print and scan. Any struct that implements these methods can then be treated as a printer by the computer. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website, across the globe, www.atg.world. Interfaces in Go provide a way to define a set of methods that a type must implement. This promotes code reusability and flexibility by allowing different types to be used interchangeably if they fulfill the interface contract. In the code snippet provided, we start by defining the printer interface with two methods, print and scan. The myPrinter struct is created to represent a printer and implements the methods required by the printer interface. The usePrinter function demonstrates the usage of interfaces by taking a printer interface as an argument. This function then calls the print and scan methods on the object that implements the printer interface. By creating an instance of myPrinter and passing it to the usePrinter function, we showcase how a concrete type can be treated as an interface type. This enables us to work with multiple types that adhere to the defined interface without modifying the function's implementation. Real-world applications of interfaces in Go include defining common behavior across different types, allowing for code extensibility, and facilitating unit testing by mocking interfaces. Interfaces play a crucial role in achieving loose coupling and promoting polymorphism in Go codebases. One industrial application of interfaces in Go can be found in database drivers. For instance, when working with different databases like MySQL, PostgreSQL, or MongoDB, they each have different implementations for connecting, querying, and interacting with the database. By defining a common interface for database operations, developers can switch between different database implementations seamlessly without changing the core logic of their application. Another real-world example of using interfaces in Go is in web frameworks. Web frameworks often define interfaces for handling HTTP requests, middleware, and routing. By employing interfaces, developers can create custom middleware, route handlers, and request processors that adhere to the specified interface, making it easier to extend and customize the web application. Interfaces in Go provide a powerful way to decouple the implementation details from the abstraction, leading to more modular, flexible, and maintainable code bases in various industrial applications. Across the globe, businesses leverage the versatility of Go interfaces to streamline development, enhance code reuse, and improve overall software quality. Keep learning, stay curious, and I'll catch you in the next video.